Hi and welcome to this video, topic 1.2, the mole concept. We're going to start looking at the syllabus for this topic. The syllabus says that the essential idea is that the mole makes it possible to correlate to the number of particles with a mass that can be measured. Actually, there are two parts of this topic. The two parts is the first is the relationship between molar mass, and amount of substance. So the first video here, we're going to look at the relationship. We're going to talk about the molar mass, amount of substance, and also the calculations when we have the relationship between these three. The second part, that is on another video, will be determining the empirical formula, and from that we can deduce the molecular formula. So this is the two part we will work with today, or this first video will be a relationship between the molar mass, amount of substance, and the second video for this topic will be about the empirical formula and the molecular formula. So we're now going to start, and we're going to start with molar mass. We're going to talk about amount of substance and the relationship with these three. This is the equation that we will work with, and you're going to work with this equation many times in chemistry. It's a really important equation, so you need to learn this. And the relationship says that the molar mass is the mass divided by the amount of substance, and this is what we can use later to do calculations on chemical reactions. Like if I let this mass and this mass of two different substances react with each other, how much can I get of the product? Then we can do the calculations before we do the experiment. So the whole thing here is the starting of the calculations of chemical reactions. So molar mass is the mass divided by amount of substance. I'm going to get through every part of this one and what it is and how you can determine it. The only thing I think that you know really now from the beginning is maybe the mass. We use that in a normal day life, and this is the unit we have for each part of the equation. The mass in this equation will have the unit of gram, and yeah, I'll go through them one by one. We're going to start with molar mass, and when we work with molar mass, you also need your chemistry data booklet and the periodic table. So that is section number 6 in your chemistry data booklet, and you find it here, and you're going to look at the value that is beneath the element, because that is the relative atomic mass for each atom. So these values you need in order to determine the molar mass for an atom, or maybe if it's a compound, you will add them together. So section number 6, and maybe also your calculator, have that next to you. The molar mass has the units of gram per mole. When you write it, you will write it like this. Okay, but that actually means gram per mole, and the reason why I also write it like this is because that can show us the equation, gram per mole. Okay, so that is the molar mass, gram per mole. In later, we can convert molar mass to gram, that is the mass, divided by the amount of substance. We can see the equation in the unit of the molar mass. So that is why it's good to know this one here. Okay, so we're going to use the values in the periodic table to calculate the molar mass for an atom, or maybe for a compound. Important that you don't forget the unit. The unit tells us also the relationship, and we can later use that when we do the calculations. So we have three different here now. We want to calculate the molar mass for carbon dioxide, and then we have sucrose, that's sugar, and then we have diammonia carbonate here. Okay, the molar mass for carbon dioxide, I'm you try to write it like this. The big M says the molar mass, and then we have the compound in a parenthesis. And then what you do is that you go to section number 6 and you find the molar mass for each atom. In this case we have 1 carbon and 2 oxygen. Carbon has the molar mass of 12.01, so you write this here. And then you have 2 oxygen. Oxygen has the molar mass of 16, so you take 16.00 times 2. Then you put this on the calculator, and if you do that you will get the molar mass for the carbon dioxide to 44.01 gram per mole. Okay, we take one more. We can take this one here, C12H22O11. We have carbon, we have hydrogen, we have oxygen. We know that carbon has 12.01. We have 12 of them, so we take it times 12. Then we have hydrogen. The molar mass for hydrogen is 1.01. And times 22. And then we have oxygen, that's 16.00, and we have 11 of them. Now you can add this together, and if you do that on your calculator you will get 342.34 gram per mole. Okay, now I want you to click on the pause button soon. I want you to try on your own to determine the molar mass for this compound. Try on your own. I will soon give you the correct answer. Okay, the correct answer for this one will be 96.11 gram per mole. So double check your answers with this one here. Hope you get it correct. Okay, so that was the molar mass. We're going to continue in this equation. The next part I'm going to talk about is the amount of substance, also notated as a small n. The molar mass was notated with a big M, the amount of substance with a small n. The n, or the amount of substance, is actually how many particles you have. Like if you take them out one by one and count them, how many particles do you have in the mixture? So you're going to take them one by one. And actually if you want to find the number of particles, like in a glass of water, that will be quite a big number. So it's inconvenient to work with this big number. So what we do is that we call it mole instead. And the definition for a mole is actually 6.02 times 10 up to 23 particles for 1 mole. And that is nothing that I have made up. It's actually something we use worldwide. So this is actually a big number. We can see times 10 up to 23. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So it's a big number, right? So instead of using these big numbers, they have said that 1 mole is equal to this one. So when they say mole, that is due to this big number. And that is when you count them one by one. The unit for amount of substance is mole. The last part of the equation was the mass, and that is what we put on the scale. The unit for mass, we notated the mass with a small m, and the unit will be gram. I know that the SI unit is actually kilograms, but in the calculations we're using only gram. Okay, now we're going to look at the calculations. We're going to start with this relationship again. The molar mass is the mass divided by the amount of substance. Think of the unit, gram per mole, so the mass should be there and the amount of substance here. Okay? So think of the unit for the molar mass, see unit, then you can see the equation. Okay, I have some different tasks here. I will explain some of them for you. We're going to start out with this one. I think I will take some of them. I will just give you correct answers. I think I will take this actually, the last one. What is the mass in gram of a 0.5 mole sample of sucrose? Well, the N for sucrose is given in the assignment here. The 0.500 mole. And they want to know the mass, okay? So that is the thing here. The molar mass you can always know. You know it indirectly because if you know the compound, you can look at the periodic table to determine the molar mass. And we did that just a second ago. We know that the molar mass for C12H22O11 is 342.34. You can double check the calculations by looking at the periodic table if you want to. So now we're going to calculate the mass. We know that this is the equation. So the mass is actually the molar mass times the amount of substance. And if you put that on your calculator, you will get 171 gram. So that is how you can use the equation to calculate. So if I say to you, okay, now I want you to put on the scale 0.5 mole of the sucrose here, then you need to know how much is that in mass. Then you can recalculate it from the amount of substance to the mass by the help of this equation. I think I will show you one more. We can take the first one actually. Here you use Avogadro's constant. As I said, 1 mole is equal to 6.02 times 10 up to 23 atoms, particles, and so on. Okay, and if you have 3 mole of tin, how many atoms are there in 3 mole? Well, then you take the N divided by the Avogadro's constant to get the actual number of particles. So what we do here is that we take 3 times 6.02 times 10 up to 23. This is one number here. And now you will get 1.8 times 10 up to 24 tin atoms. I will also show you on the calculator because this is one thing that you need to learn how to do this. My recommendation is that you put this number first. 6.02 times 10 up to 6.02 times 10 up to 23. Double check that this will be correct. So I press enter to get this confirmed, and then I multiply the answer with 3 to get this answer here. And in this case you have 1 decimal place in the question, so I have 1 decimal place in the final answer. You can try on your own for the other one here. I will just give you the answer here. So click on the pause button now and try on your own, and I will just put the final answer. Okay, so here is the final answers. This one here, you need to look at the mole ratio. You can see that this is the number of molecules of the ammonia. They want to know how many hydrogen atoms there are inside this one. Then you can see it's 3 hydrogen atoms for every ammonia. So the relationship here is that 1 mole of the ammonia is equal to 3 mole of hydrogen atoms, because it's 3 hydrogen atoms in every of these molecules. So we'll actually take this 3 times this one here. Also this one here, you will know how many mole there are. Then you just take this number divided by the Avogadro's constant to get the final answer. Yes, so this was the first part of topic 1.2, the mole concept. Thank you for watching.